So this first video is going to be about random sampling, and people get confused about the idea of random sampling, and let's just break it down to why we do random sampling. If I told you to go out to this field, and I say this field is, I don't know, 200 meters by 100 meters, so absolutely enormous, and so can you find out how many daisies are in that field for me? You would say, are you mad? That's going to take us 3 days, and you'd never do it in a million years, which is totally understandable. So, random sampling is all about cheating and getting a decent estimate of how many daisies there are in that field by scaling up. So what do I mean by that? So, this is how I would do it if I were you. So let's just say, for sake of ease, this field is 100 meters by 100 meters. So still a pretty massive field. So if we figure out very quickly how big that is in terms of area, that's 100 times 100. So we've got 10,000 meters squared. Therefore, we need to basically take some estimates. And the way you would do that is you would get your quadrat and you'd place it down somewhere, and you go, right, in this quadrat I've got one daisy, that one's not over half, that one's not over half, so I'm not going to count it. So in my first quadrat I've got 2 daisies. Then I will lay down another quadrat, and I'll go, okay, 1, 2, 3, 4, 5. So there's 5 there, that's over half in my opinion, that's over half in my opinion, that's over half in my opinion. So I can say in the second quadrat there are 5. And let's just look in this third one, and we'll look through here. So let's just go here. In this third quadrat there are 2. So let's top them all up. So we go boom, boom, boom. That is 9. So in 3 meters squared, in 3 meters squared, there were 9 daisies. Therefore, I can predict that actually in 1 meter squared, so that's cubed, will equal 3 daisies. So I can now very lazily and probably quite inaccurately, given that we've got 1,000 meters squared, I'm just going to times this by 10,000 to give me my 10,000 meters squared, and then I can say there's probably 30,000 daisies in that field. However, how are we going to make this an accurate, valid sort of sampling method? And the answer here is you need to sort of remove biases and stick to the same rules. So the first thing is, how are we going to decide whether it's in or out of the quadrat? Quadrats aren't going to, you're going to get unlucky sometimes. So what we were doing on this one when we looked at here was I said it's always over half. So that's like a rule that you can stick with. As long as you stay with that rule throughout, then you should be okay. So that'll give you a nice some valid results. The other thing is randomizing where you are sampling. So it's very easy to sort of go, oh, that one's got lots, let's go over there. And you will just get attracted to the places where there's loads, like this little cluster. We don't want that. You want to make it random. And some people will then go, okay, so what I'll do is I'll stand over here, face this way, and lob it over my head. And that isn't random either, because basically what's going to end up happening is you'll end up hitting the middle bit loads. And if you're right-handed, as you lob it over your head, you'll sort of tend to go that way. If you're left-handed, you'll tend to go that way. You'll very rarely drop it right behind you. And if you can throw a quadrat 100 meters, fair play. So we're not going to do that because it's a dumb idea. So what you have to do is use a random number table. So for example here, you can get these off the internet. You can actually, there's a random number button on your calculator. And what you can do is you go bang, and it'll be like, okay, so 0, 30 is how we're going to do it. So 0 on this axis. So I'm starting right at the beginning, and then you go 30 meters along here, and you're like, cool, I'm going to plonk my quadrat down like that. And then you do the next one as well, and that will remove any biases, make sure you have a truly random sample. So that is random sampling.